had told you before in the class that I'll be sending you a video of the sums of finding various terms like like the potential difference, current, resistance, terminal voltage drop. Okay, so we will be doing such type of sums, that how from the circuit given you'll be finding out various factors. Okay, now the sums, 10 sums I'll be doing, and those sums which I'm doing on the video, I'll be sending you the sums in your I'll be sending you those sums. Please write down those sums first and then look at the video. Then it will be more easy for you to understand those sums. Okay, so let's start with the sums on finding the potential difference, resistance, current, terminal voltage, EMF, whatever we require it. Let's see. Okay, so starting with the first sum. So first sum, it's given two resistors of resistances 4 ohms and 6 ohms are connected in parallel to the cell or to a cell to draw current 0.5 ampere from the cell. Draw a diagram of the arrangement. So let us draw a diagram of the arrangement. Suppose this is the cell and there are two resistances which are connected in parallel. Okay, so that means let this be one resistance, let this be another resistance, and as they are connected in parallel, see, I have drawn them connected in parallel. Okay, so this is the circuit diagram. Let us mark the various terms which are given over here. So what are the resistances? 4 ohms and 6 ohms. And what is the cell? What is the current flowing through this? It is, suppose I am marking an ammeter over here which measures the current. Okay, so the current, it is showing 0.5 ampere. Okay, what they have asked, we have drawn the diagram as it is given. Now they have asked, calculate the current in each resistor. There are two resistors, 4 ohms and 6 ohms. Now students, if in a circuit if it is connected in parallel, okay, first of all you have to find out the potential. I told you in a parallel circuit the potential difference is the same. Potential difference is same of the two resistors, but the current is different. Okay, so let us find, first we will find the combination of these two resistors. Okay, so now obviously they are connected in parallel, so 1 by R is 1 by 4 plus 1 by 6, which is equal to 12. 4 3s are and 6 2s are, that means 5 by 12. So R is equal to 12 by 5. Okay, you can convert it into decimal, so it will come as 2.4 ohms. Okay, so the resistance, the combination of these two parallel resistances, 2.4 ohms. Okay, now what is the total current? So this is the total resistance of the circuit R. Now what is the current flowing in the circuit? 0.5 ampere. Okay, so what will be the voltage or potential difference across the circuit? What is the formula? V is equal to R into I. That means R into I, which is, what is the value of R? 2.4. What is the value of I? 0.5. Okay, so here you will be getting the, what you will get? You will get the potential difference. Okay, once you get the potential difference, okay, so it will come out as 1.2 volts. Okay, now it becomes easier for you. Okay, so you know that the potential difference across this two ends is 1.2 volts. Okay, now you have to find out the current through each resistor. Suppose the current through 4 ohms is I1 and the current through 6 ohms is I2. Okay, so let us find, so how will you find out I1? I1 is nothing but 1.2 means the formula of I is nothing but, see, V by R. Okay, V by R1. Suppose this is R1 and suppose this is R2. Okay, so what is V? What is the potential difference? 1.2 volts. What is R1? It is 4. Okay, so if you divide, you will get I1. Now to find out I2, so what is V? 1.2 volts. What is R2? 6. Okay, so find out, divide, and you will get the value of I2. Okay, so the first thing, students, you will be coming across parallel circuit and you will be asked to find out the current through the 2 or 3 whatever resistors it is given. Okay, now there are various ways of doing this sum, but I would suggest you that whenever this parallel circuit is given, students, first find the potential difference at this end. How will you find out the potential difference? Obviously current will be given to you, or you will find out the current flowing through the circuit. Okay, So after finding the current through the circuit, you will find the combination of these two resistances. What is the combination of these two resistance? Okay, so just resistance into the current will give you the potential difference at this end. Remember, when it is parallel circuit. Okay, so for finding the potential at this end of the parallel, this type of sums are very common. So remember, to find out the potential difference at the end of two parallelly connected resistances, you have to find out first the combination of these two resistors and just multiply it with the current which is flowing through the circuit. And you get the potential difference across these two ends. Not just divided by the potential difference with individual resistors, you get the current passing through the various resistances. Okay. Now, let us do the next sum. So, students, the circuit, the drawing of the circuit, if you can analyze the drawing of the circuit, the sums of this one is very easy. Now, coming to the second sum. In the figure given below, they have already given a figure. The figure goes like this. This is a cell. There is a voltmeter over here. Okay, the voltmeter is there. Then this is connected over here. There is a ammeter which is reading 0.4 ampere and this is reading 4 volts. Okay, there is a cell. Now, after this, there is another resistance of 20 ohms and another resistance R. Okay, this is 20 ohms and this is R. Nothing else is given over here. Okay, now let us read. This is the circuit given. Let us read the question. They have asked in the figure given below, calculate total resistance of the circuit. As you can see, students, these two resistances, they are connected parallel. Okay, and also this R is unknown to you. But to find out the unknown resistance R, they have asked the total resistance of the circuit. Okay, so to find out the total resistance of the circuit, students, first you have to find out, means this is unknown to you. So how will you find out the total resistance of the circuit? You cannot. So what will you do? See, we know, see, V is given as 4 volts, I is given as 0.4 ampere. Okay, total potential difference is 4 volts and current is 0.4 ampere. So what is the formula of R? R is equal to V by I, okay, which is your 4 by 0.4, which is your 10 ohms. Okay, so you have got the total resistance as 10 ohms. Okay, now as you have found out the total resistance of the circuit, now you can easily find out the unknown resistance R. Why? Because this R, this is connected in parallel. So we can say that 1 by R plus 1 by 20 is equal to the total resistance of the circuit, which is 1 by 10. Okay, so if you solve it, you will get R. Okay, I hope you know how to solve it. If you can't, please see here, 1 by R is equal to 1 by 10 minus 1 by 20, okay, which is equal to 20 LCM. So 2 minus 1, which is 1 by 20. Okay, so if 1 by R is 1 by 20, so R is equal to 20 ohms. Okay, that means this unknown resistance R is 20 ohms. Okay, now after this, let us see the so we have solved two portions. One, we have got the total resistance. Second part, they had asked the value of R and we have found it. Now the current flowing in R, again the same thing. Okay, so these two are connected in parallel, students, and what we have got and what will be the parallel connection of these two resistances? Just now you have got, it is 10 ohms, right? So what is, they have asked the current, they have asked the current in the current to flowing in R, means this one. Okay, so what is the current flowing? IR. Suppose IR is the current. So what is the parallel combination of 1 by 20 plus 1 by 20? 10 ohms. Just now you have got, because there are two resistors only in the circuit, and you have got the total resistance as 10 ohms. Okay, so R is 10 ohms. What is the current passing through it? 0.4 ampere, because I is nothing but this one. I is equal to means, sorry, what they have asked, the current flowing through R, sorry, I is V by R. Okay, so IR is V by R. Okay, so what is V? What is the potential drop across? So first you have to find out the potential drop. Okay, so V by R, let us find out the potential drop. What is the current? Okay, so let us find V. V is equal to I into R. What is the combination of resistances? 10. What is the I? 0.4. So what is the potential drop over here? It is 0.4 into 10, which is 4 volts. Okay, so you have got the potential difference as 4 volts. Now put it over here. So 4 by 20. Okay, so 4 by 20, solve it, and you will get the value of this one, your I, as 0.2 amperes. Okay, so again we have done it again over here, students. Remember, to find out the current through any of these two circuits, students, first you have to find out the potential difference across these two the parallel connection. So for that you have to do V is equal to I into R, and 1 by 20 plus a 1 by 20 as they are connected in parallel. So it is giving you 10 ohms and I is 0.4 ohms. So it is coming 4 volts, and I is coming as V by R, which is 4 by 20, which is 0.2 ampere. Okay, students. So this is how you're going to do the sums. Okay, remember, main thing is the parallel circuit. Okay. Okay, student. Now let's see sum number 3. What is sum number 3 telling us? So sum number 3, again a circuit is given. So till now, in the last two sums, students, we have done sums with parallel circuit. Okay, now we will be doing sums with parallel and series, both combined. Okay, just remember that whenever parallel resistances are given, please find out the potential difference across these two parallelly connected resistors. Okay, to find out the current through each resistor. So here a circuit is given, two circuits. Okay, one is 2 ohms, one is R ohms, again R ohms sum, and this is given as 4 ohms. Okay, so this is current is given as 0.25 ampere. Okay, this is 2 volts, this is 3 ohms and 2 volts. Now see here, students, here 3 ohms is given along with the cell. Look here, students, 3 ohms is given along with the cell. See, for other things you get a separate, you are getting a separate resistance, but 3 ohms is given with the cell. That means this 3 ohms is nothing but the internal resistance, small r. Okay, so the resistance which is present along with the cell is nothing but the internal resistance. I have already told this in the class when I was teaching you internal resistance. Okay, but when you will be calculating the total resistances, remember small r is also counted along with the other resistances. Okay, because this also is affected. It also creates an effect on the working of the circuit. Okay, so let's see what the sum. So in the figure given below, it's given, as you can see, this 2 ohms, R ohms, 4 ohms resistance and internal resistance of 3 ohms. Okay, the main current is 0.25 ampere. They found out, find the potential drop across 4 ohms resistor. Okay, now before doing any other sum, students, whenever R is given, first you find out the value of R. Okay, finding value of R is very important. Okay, so let us find the value of R. So one thing more is given, that our inter-resistance figure shows connected to this, the main current is 0.25 ampere flowing through. Okay, so to find out R, what is the value of V? V is given as 2 volts, I is given as 0.25 ampere. Okay, so what will be the total resistance of the circuit? R is equal to V by I. Okay, that means 2 by 0.25, which is 8 ohms. Remember, this R is not this R. Okay, this is the unknown resistance, and R, suppose let me differentiate it, otherwise you will get confused. So RT means the total resistance of the circuit, including the internal resistance also. Okay, so total resistance of the circuit is 8 ohms. Now we can easily find, obviously in the means we have to, at the last question which is given over here, they have asked you to find out the value of R, but first I will find out the value of R. Okay, so total resistance of the circuit is 8 ohms. Now you can see that this 3 ohms and 4 ohms, this internal resistance and 4 ohms, they are connected in series. Okay, so 3 plus 4 is connected in series. Okay, and what plus, suppose I name this as RP, parallel circuit. Okay, is equal to 8. Okay, 8 is the total resistance of the circuit. Okay, So what is 1 by Rp? It is nothing but 8. This 3 plus 4 is 7. So 8 minus 7, it is 1. Okay. So 1 by Rp. Now let us write the values. 1 by 2 plus 1 by R is equal to 1. So 1 by R is equal to how much? 1 by 2. 1 minus 1 by 2, which is half. So what is R equal to? 2 ohms. So you have got R value as 2 ohms. We have done one portion of the sum, which is the fourth portion of the sum. Okay, we have got the value of R. Now, what they have asked, potential difference across 4 ohms resistor. Now, students, remember only in case of parallel circuit, the current is different. Okay, but in other cases, if you talk about potential difference in series, you just have to multiply the resistance with the current to get the potential difference. Okay, and to find out the potential difference across the parallel end, students, you have to find the combined resistance first. Okay, that means you have to find out the Rp part. So as you can see, we have already got Rp as 1. Okay, or you can see it for yourself. If you combine 1 by 2 plus 1 by 2, half and half, what do you get? 1. Okay, that means the parallel combination of this two, that means the parallel combination is nothing but 1 ohms, this two portion. Okay, so to find out the potential difference, students, because you know that in a parallel circuit, the potential differences across the two resistors is the same. So we have already got the parallel resistance, total resistance. Now we can easily find out the potential difference. So first they have asked the potential difference across the 4 ohms resistor. So this 4 ohms resistance, what will you do it? Very easy. Potential difference V is R into I. What is the value of R? 4. What is the value of I? 0.25. Just multiply and get the answer in volts. Okay. Next question. The potential difference across the internal resistance of the cell. What is the internal resistance? 3 ohms. They are all connected in series. So we have to just multiply the resistance with the current. Okay. That means 3 into 0.25. Okay. So you get the answer, and that is the potential difference across the 3 ohms resistor. Internal resistor. Okay. Number C part. Number C part, there are potential difference across the R ohms or 2 ohms resistance. Now as I told you, R ohms, 2 ohms, they connect in parallel, and we have got the parallel resistance as 1 ohms. So what will be the potential at this R ohms and 2 ohms? It is nothing but 1 into 0.25, which is 0.25 volts. Okay, and the D part, they have asked value of R. We have already found out the value of R, okay, which is equal to 2 ohms. Okay, so just students, you have to remember one thing in solving of this type of sums, that in parallel, if it is series, it is very simple. But if it is parallel circuit, first whenever you find in the sum parallel circuit, first if it is R, like this type of sum where you have to find out R, first find out the value of R. After finding out value of R, find the combined circuit by adding them parallelly. Okay, find out the combined sum of the parallel one. After finding, then you go to do what the question is asking. Then you will easily, your work will be done, and you can easily do the sum. Okay, because you see that in finding current or you finding voltage, you require the parallel combination. So that's why I'm telling you, whenever parallel circuit is given, please first find the total parallel circuit. Okay, what is the total sum of the parallel connections? Okay, next let us do the fourth sum. Okay, what is the fourth sum? So you do this type, you practice this type of sum, it becomes very easy for you to do this sums. Okay, number 4. So just simple Ohm's law you have to remember over here. Okay, so let us do the fourth sum. Fourth sum, again a circuit is given. Let me draw the circuit quickly. It is 6 volts. Okay, remember that along with the means potential difference, if along with the cell, whenever the your resistance is given, that means that is the internal resistance of the cell. So there are two resistances, as you can see. This is the parallel circuit. It is given R1 is 6 ohms and R2. Okay, there is a parallel circuit. There is a circuit over here. R2 is given as 2 ohms and R3 is given as 4 ohms. Okay, so as you can see, first whenever this sum is given, this is given as 6 volts. Okay, so whenever this type of sum is anything else, no, whenever this type of sum is given, students, first solve the resistance part. Okay, so let us solve the resistance part. Let us find the total combination of resistances. So as you can see, this 2 ohms and 4 ohms, they are connected end to end. That means they are connected parallel. So 2 plus 4 gives us 6 ohms. Now you're accustomed with calculating of resistances, so you can do it verbally also. So what will be the total resistance of the circuit? Suppose R is the total resistance of the circuit, or let me write RT. Okay, so what is this 2 plus 4 is connected in series. So 2 plus 4 is 6, plus this is connected. Now these two are connected in series, but this is connected in parallel. Okay, that means 1 by 6 plus 1 by 6, which is equal to 2 by 6, which is equal to 1 by 3. So total resistance is 3 ohms. Okay, so you have find out the total resistance. Now they have asked effective resistor of circuit. We have already found out the effective resistance, which is 3 ohms. Okay, next, reading of the ammeter. Very easy. What is the formula of I? I is V by R. What is the value of V in the circuit? 6 ohms, 6 volts, sorry. And what is resistance? 3 ohms. So what is the current? 2 ampere. Okay, so see, this sums is so easy. Only the thing is that first solve the resistance part, especially if it is connected in parallel. Okay, next, let us do the fifth sum quickly. Hope the sums, you are understanding these sums. Students, the sums are not at all tough. Just you have to stick to your basic and try to do this sum. Fifth sum. Fifth sum, let me draw the ray diagram. There is an ammeter over here and there are two parallel resistances. Okay, one is 10 ohms and one is 10 ohms. 10 ohms and 40 ohms. Then there is 1.8 volts. Okay, there is a that is the cell. Next, there are 3 more resistances connected over there. Okay, so there we have 2 parallel circuits over here. Okay, now sum is not at all complicated. Okay, just we have to stick to the concept. Okay, 30 ohms, 20 ohms and 60 ohms. So this is the sum given to us. So as I told you, students, first we will find the resistances. Okay, before seeing any other part, first find out the resistance. Now since there are 2 resistances, we will find them separately. Okay, suppose this set is R1 and this set is R2. As you can see, all are connected in parallel. So what will be 1 by R1? 1 by 10 plus 1 by 40. Okay, so I'm directly doing it. 3 plus 1, 4, 40. So it is coming as this one, 3 plus 1, 4 by 40, which is sorry, not 4 by 40, sorry. It is 4 plus 1, 5 by 40, which is 1 by 8. That means R1 is coming as 8 ohms. Now let us come to the combination of R2. What is R2? 1 by 30 plus 1 by 20 plus 1 by 60. If you solve it, 60 is the this one. 2 plus 3 plus 1. That is 6 by 60, which is 1 by 10. That means R2 is nothing but 10 ohms. Okay, so the effective resistance over is 8 ohms and the effective resistor over here is 10 ohms. Okay, now let us go to the sum. We have done the half part of it. Now they have asked total resistance of the circuit. See, we have already done the 2 parts. Now just these two effective sets, R1 set and the R2 set, they are connected in series. So just add. So total, suppose RT is the total resistance of the circuit. It is nothing but R1 plus R2. How much have we got? R1? 8. How much have we got? R2? 10. So what is the effective resistance? 80 ohms. See, so easy. Now what they have asked? Reading of the ammeter. Very easy. Okay. So reading of the ammeter means I you have to find out. What is the formula of I? V by R. Okay. So what is the value of V over here? 1.8. Okay. I'm writing over here. And what is the value of RT? That means total resistance. Since they are asking the current reading of the circuit, total circuit resistor, total current. So we will take total voltage by total resistance, which is 18. Just solve it and get the current in ampere. Okay. So see, the sums are so easy to solve. Okay. Just you have to understand, analyze and do the circuit. Okay. Next, let us move to the 6th sum. Hope you are understanding the sum, students. The sums are very important for your ICSE part, especially finding out this different components of this, finding resistance, finding potential difference are very these are very common sums. Okay. Now Let us do the sixth sum. The sixth sum, it is telling, I'll not read the question. I'll first draw the circuit. If you draw the circuit, after that circuit means whatever is given in the circuit. So see, again internal resistance has come. Okay. After that, the ammeter reading is given as 0.0. Again, any resistance is there. Okay. Another 4.5 and this is 9. Okay. So there are 4 resistances in total. Okay. So let's solve the sum. Before solving the sum, as I've told you, first I will find the resistance. Let this be the parallel. Let me first find the parallel circuit separately. So what is Rp equal to? 1 by 4.5 plus 1 by 9. Okay. So which is 9 is common. So 2 plus 1, which is 3 by 9, which is 1 by 3. So Rp is 3 ohms. That means the combination of this is 3 ohms. Okay, now let me go to the sum, because see this 0.8 and 1.2 ohms, they connect in series. So it will hardly matter. If they ask the total resistance, just add all these 3 quantities, you will get the answer. Now let me see the sum. So this is the circuit given. They have asked reading of the ammeter. So to find the reading of the ammeter, what you have to do? You have to find the total resistance. So RT is nothing. This 3 ohms you have already got, plus 1.2 ohms inter resistance plus 0.8, okay, which is equal to 5 ohms. So the total resistance of the circuit is 5 ohms. Now what is the potential difference given? V, 2 volts. Okay, V is given as 2 volts. But then they are asked the I. So I is nothing but V by R, which is 2 by 5. That means 0.4 ampere. Okay, first part done. Next part, what they have asked? They had asked the potential difference across the terminal of the cell. Now, potential difference, remember, this is the only internal internal resistance of the cell, because it is present along with the cell. Potential difference across the terminal. Now, what is potential difference? Means they are asking the total potential. Remember students, internal resistance, it always gives rise to potential drop. Okay, remember, if they are asking the some potential drop, that is always created by the internal resistance. So you cannot take this portion for potential difference. So what are left? We are left with 0.8 ohms and this parallel of combination of this. That means if they have asked you the potential difference across the terminals, means you have to find V across this and V across this. So what will be V equal to? So this has come out as 3. So V is equal to nothing but R into I. What is I? 0.4. So first let us find this. What is the combination of this resistance? 3 ohms. Okay. So 3 into 0.4 plus what is another resistance given? 0.8 into 0.4. Okay. So V into Ri plus V into Ri. Because this is the terminal of the end. Remember, internal resistance always gives rise to voltage drop. It never gives rise to voltage difference. But they have asked the potential difference across the terminals of the cell. For that, you will multiply the resistance, total resistance, combination of the total resistance into the current. V is equal to R into I. Also, there is another resistance present over here. So, resistance into the current. Okay, if you add this two, you will get the potential difference. So, please multiply and add it and you will get the answer. Next, potential difference across the 4.5 ohms resistor. Okay, very good. So, 4.5 or 9, whichever it is given, as you know, as the 4.5 ohms and 9 ohms, they connect in parallel. So, we will take the parallel combination. Okay, so what will be the potential difference across 4.5 ohms? It is nothing but V is equal to R into I. What is R? 3. What is I? 0.4. That means 1.2 volts. Okay, so that's why I'm telling you, whenever parallel circuit is given, because whenever parallel circuit is given, students, whenever you're writing, you have to find out potential difference, the combination of resistance is taken. That's why first solve the parallel circuit. Then only you go for anything else. You calculate current, you calculate potential difference. You will always require the combination of these resistances. So please do the parallel part first. Okay. So we have done this sum. We have found out the various potential differences. Remember, potential drop is created by internal resistance. So I have not taken this internal resistance when I had calculated the potential difference across the cell. Across the cell means total cell. Okay. Now let us do the seventh sum. Now seventh sum. Let us see what is the seventh sum. Seventh sum is given. Let me draw the circuit quickly, students. So this is given. Now slowly I'm entering. Now I'm going to enter into the, after few, there's one potential drop and terminal voltage. I'll show you. Okay. So the circuit is given. Let us do the circuit. So main analysis of the circuit. Circuit will be given to you. You just find out the circuit. Okay. The sums become easier. Okay. So this is the circuit given. This is given as, E is given as 9 volts. This is given as 1.5 ohms, 3 ohms, 6 ohms, 12 ohms. Okay. So before that, first I told you we will find out the resistance. So suppose this is the R1 side, this is the R2 side. R1 side means the total. Okay. So what is 1 by R1? 1 by 1.5 plus 1 by 3. Okay, which is coming out 2 plus 1, 3 by 3, 1 ohms. Okay, I've done it directly. Please, you try to do it yourself. And R2, it is nothing but 1 by 6 plus 1 by 12. So 1 by R2. So R2 will be equal to 6 2s are 1, 3, 2 plus 1, 3, 3 by 12, which is 4 ohms. Okay, so R1 is coming out as 1 ohms, R2. So this parallel combination of these two resistance is 1 ohms and the parallel combination of these two resistance is 4 ohms. Okay, now what they have asked? They have asked current in the main circuit. That means full circuit. So obviously we have to find out the total resistance, which is 1 plus 4, because after parallelly they are connected in series, which is 5 ohms. You know total resistance. What is the potential difference? E, 9 volts. So what will be I? It is E or V, same thing. So V by R. Okay. So which is equal to 9 by 5. Just divide it. I'll get the current. Okay. Next. Current in each of the resistors in the parallel circuit. Okay. Current in each of the parallel circuit. That means this whole and this whole current. That means through 1.5, 3 ohms, 6 and 1.5. Now to show you that, let me first solve the let me find out the I value. Again I'm telling you there are different methods of finding out the current through each resistor. Okay, but I am sticking to my basic, which is where I have shown you that I will find out the potential difference and then divide by the resistances to solve the sum. Okay, so it is coming out as 1.8 ampere. Okay, I found out. Now, what is the combination of this resistance over here? 1 ohms. So, what will be the voltage? Suppose V1 is the voltage drop across this side. So, it will be I1, not I1, I into R1. R1 is the parallel combination of the two resistors. That means 1.8 into 1, which is 1.8. And what will be V2? 4 ohms into 1.8. Okay, if you don't want to multiply, don't multiply, just keep it as it is. Afterwards you can solve it. Okay, now so we have found out the potential at this end is 1.5 volts, and at this two end it is 4 into 1.8 volts. I have not solved it, I have kept it so that we can do it afterwards. Okay, so first they have asked you the current through each resistor. So let us take the 1.5 volts. Okay, so first one, 1.5 volts. Okay, current across 1.5 volts. So I 1.5 ohms, it is nothing but 1.8 by 1.5. Why? Because in parallel combination the potential difference is the same. So potential difference divided by the resistor will give you the current. So you'll get the I value over here. Similarly 1 and 3 ohms. Yes, 3 ohms. So it is nothing but 1.8 by 3. Just divide it and you'll get the answer. Now coming to this circuit. This is the total total potential difference. I have not found it. Okay. So here also suppose I3. Okay. So it is nothing but 4 into 1.8 by 6. Okay. And I4. This one is nothing but 4 into 1.8 by 12. Okay, so this way what will happen, you will get the current through each resistor. Okay, so again I'm telling you, to find out the current through each resistor, first find out the potential difference across the parallel circuit. Okay, if you can find out the potential, just divide it by resistance, you'll get the sum. Okay, there's another way also of doing it, but I want to stick to my basic. Okay, there are various ways of doing this sum. Okay, so this is the 7th sum. Now let us see the 8th sum. So please solve I3, I4, I1 and I2 also. Okay, this 2 and this 2, please solve it. I have done it. Just note down the value, solve and get the answer. Now 8th sum. Let us do the 8th sum now. So I'll be sending you the sum. Don't worry, students. So you just see the circuit and try to do it. Okay. Now 8th sum. 8th sum and 9th sum, basically it deals with your potential drop and your voltage drop. Okay, put a voltage drop, and 9th sum deals with terminal voltage. Okay, so let us quickly draw the circuit. This is E is given, E or V is the same thing. Okay, there is a resistance given over here, which is R is 1 ohms. Okay, that means this is the internal resistance. Yes, 1 ohms. This is the internal resistance. Okay, R. That's why. So this is the next circuit is given is 4 ohms. Okay, that is R1, and there is another resistance R2, which is 20 ohms. Okay, so this is the sum. So before proceeding any further, let me find the total. I will require the total resistance. So let me find out the total resistance. It is nothing but, since it is series connection, it's very easy sum. So it is 1 plus 4 plus 20. That means 25 ohms. Total effective resistance is 25 ohms. Okay. So what they have asked, current in the circuit. See, we require it. That's why. So current I, total current is nothing but V by RT. What is the value of V? 1.5. What is RT? Just now 25. Just divide it, get the answer. Okay. Potential difference across each resistor. Okay. So this is series connection. So you don't have to do anything. Just you find out. Now, obviously I will require the I value over here. So I'm just solving it. It will come out as 0.06 ampere. Okay. I. Now, R1. To find out R1, potential difference across I, R1. So suppose V1 I am remaining. It is nothing. I, R1. So what is 0.06 into 4? Series sums are very, very easy, because here you don't have to do anything. Just multiply with the resistance. And next they have asked potential difference across each. So R2 also let me find out. Then I will show you R2. That means 0.06 into 20. Okay, so you multiply, you will get the potential difference across this and this, 4 ohms and 20 ohms. Now, the potential difference across the cell. Now, remember I told you internal resistance does not does not produce any effect in potential difference. It gives rise to voltage drop. So I will not calculate the voltage difference over here. Already I have calculated it. So to find out the total voltage, it is nothing but V1 plus V2. Just multiply, add this 2, and you'll get the total potential difference across the cell. Okay, very easy. D. Now coming to the main part. So this is the B part, this is the C part, this is the A part. Okay, now coming to voltage drop. Just now I told you voltage drop is created by whom? The internal resistance. So it can be done in 2 ways. Okay, to find out the voltage drop, you can either multiply I into R, which is 1 into 0.06, which is 0.06 volts, or you can subtract the total potential difference. Okay, or E, or rather E. Okay, 2 ways, alternate ways, same way. This is one way, this is the first way. I am showing you the second way also. You can also subtract the total EMF of the circuit minus the voltage drop. Okay, from here you will get the voltage drop, and the total EMF is 1.5 volts, and you will see, students, you will get 0.06 volts. Please solve it and see that yes, what ma'am has told, it is correct. So if you can find out V, get the value of V. E is already given as 1.5. So 1.5 minus the V you will get. Subtract, you will say you are getting the same answer. 0.06 volts. So there are two ways of solving this voltage drop. Either you multiply the current, total current, with the potential, with the internal resistance, or you subtract the total EMF of the cell with the voltage drop across the resistances. You will get the voltage drop. Okay, potential difference across the resistors. EMF minus the potential difference across the resistor, you will get the voltage drop. Remember, voltage drop is only created by the internal resistors. Okay, students. Now let us do the ninth sum. This is the circuit of the ninth sum. There is a A resistance 2 ohms, B resistance and C resistance connected in parallel, which is 4 ohms and 6 ohms. There is 9 volt and there is an internal resistance R of 0.6 ohms. Okay. So as I've told you, first I will find out the parallel circuit and the total resistance. Okay. So parallel circuit. So suppose I name it as RP. So it is nothing but 1 by 4 plus 1 by 6, which is 12. 4 into 3 plus 2, that means RP is coming out 12 by 5. Okay, which is nothing but 2.5 2s are 10, 2.4 ohms. Okay, I'm also finding the effective resistor. So this total is 2.4 ohms. Okay, so what will be the effective? 2 ohms plus 0.6. So it is 2.4 plus 2 plus 0.6, which is nothing but 5 ohms. Why I am finding effective resistance? Because at one point you will require the total resistance. Okay. Now let us see the sum. What they have asked. They have asked the first one. They have asked the combined resistance of B and C. See, we have already solved before they have asked. What is the combined resistance? This one B and C. We have already seen. See, we have solved. We have got us 2.4 ohms. Done. Next, total resistance B part. This is the A part we have done. B part we have already done. See, total resistance. Total resistance of, they have not asked the effective. Total resistance of A, B and C. So we have already got B and C as 2.4. So R A plus B plus C is nothing but 2 plus 2.4, which is 4.4 ohms. Done. C, total resistance of the circuit. So we have done the C part as 5 ohms. Very easy. Now, potential drop across the internal resistors. Now, to find out potential drop, we have to first find out what? The current. So, what is I? It is nothing but V by R. What is the value of V? 9. What is the value of R? It is 5. So, I is 1.8 ampere. Done. Now, you can easily find out the D part. So, potential drop is nothing but I into small r. See, small r is given. So, that means 1.8 into 0.6. And you will get the potential, voltage drop. Okay, next. So, we have done the D part. Okay. Next, they have asked the current in each resistor A, B and C. See, to find out this one current in A resistor is very easy. B and C already we have got the combined resistance. We'll find out the potential difference and just solve it. Okay. So students, I'm just rubbing this part because there is less space on the board. So A, B, C part we have done. The rest of the sums I'm showing you. Okay. So you know what is the combined resistance. It is 6 ohms. So what is let me solve the current. Okay, so A resistance is very easy. A resistance is nothing but the potential potential difference across A is very I into R. That means 1.8 into 2. Okay, very easy. Next, what they have asked? They have asked the this one current. Oh, sorry, not the potential drop. Sorry. They have asked the current in each resistor. Sorry. So I is nothing but since this 2 ohms is connected in parallel with this, that means the current which is passing through the 2 ohms resistor, it is nothing but the total current which we have just calculated now. Okay. Now let us find out the current in the current in each resistor. A we have already found, B and C. Okay, so B and C, to find out the current through B and C, first we have to find out V. So V is equal to R into I. What is I? 1.8. What is R? We have got 2.4. Okay, so we have found out the potential difference across these two ends. Now find out the current. So suppose this is I1 and this is I2, or IB also you can write and IC also you can write, no problem. So IB. So what is IB? It is 1.8 into 2.4 by 4. Just divide, solve it and get the answer. 1.8 into 2.4 by 6. Okay, again I'm telling you students, to find out the current, please solve the potential, find out the potential difference to get the current. Okay, so we have done the next part also. Potential difference across the resistor, B. Okay, so we have already done it. Resistor B, this one and this one. Obviously potential difference across the parallel resistors are the same. So we have already got this as the answer for the potential difference across B, which is 1.8 into 2.4. Okay, next, last, terminal voltage of the cell. Okay, so what is terminal voltage of the cell? Basically terminal voltage is nothing but EMF minus the voltage drop. Okay, so EMF, so to find out the terminal voltage, students, it is nothing but terminal voltage. Okay, it is the EMF minus the voltage drop. Okay, so voltage drop. So what is the EMF? 9. What is the voltage drop you are getting? What is the internal resistance? 0.6. What is the current? That means I think we have already found out the potential drop, right? Yes, we have already found out the potential drop. So it is 9 minus 0.6 into 1.8. I have rubbed it. So I am showing you again. Potential drop is IR. I is 1.8 and R is 0.6. So just subtract the total EMF minus the voltage drop. You get the terminal voltage. So terminal voltage is nothing but total EMF of the cell minus the voltage drop. Okay, and it will give you the terminal voltage. Okay, and again I'm telling you, voltage drop is related with the internal resistance, not with the external resistance. Okay, so this we finish off with the 9th sum. Now coming to the last sum. Now last sum is a bit different. Okay, let me solve the last sum for you. Okay, so this is the 10th sum. I hope this 10 sums, if you practice, students, I hope it will be easy for you to solve the sums, whatever sum is given to you, but you have to understand. Okay, students. So let me draw quickly the circuit given. There are two, cells given. Okay, so it is a bit different from the other sums, not so much different. Okay, so let's draw the circuit. 3 ohms, 6 ohms, 4.5 ohms, 0.5 ohms, 4 volts, 8 volts. That means you understand that there are two internal resistance present along with the cells. Okay, and there are total how many resistance are there? 1, 2, 3 and 2 internal resistance. This is R1 suppose and this is R2. Okay, and there are two EMFs or voltages, 4 volts and 8 volts. Now before I do any sum, I told you first I will find out the resistance, parallel resistance. So 1 by Rp is nothing but 1 by 3 plus 1 by 6, which is take 6 common. So you get it as 3 2s are 2 plus 1 3. So it is 1 by 2 or Rp is nothing but 2 ohms. Okay, so this parallel combination is 2 ohms. Let me find the effective resistance also. So total resistance will be 2 plus 4.5 plus 1 plus 0.5, which is equal to 6.5, 7.5, 8. Okay, total resistance of the cell is 8 ohms. Okay, so whenever you are given a sum, first find out the parallel circuit and the total effective circuit. Then let me see the sum. Now in the circuit it's given, they have asked the current, calculate the current in the circuit. Okay, so they have asked calculate the current in the circuit. So we have already found out the we have already found out the total. Okay, is there anything else? No, only current they have asked. Okay, so current in the circuit. So we have already found out the total resistance. Okay, now what is the EMF of this? So the total EMF E is nothing but E2, this is E1, E2 minus E1. Net EMF. That means 8 minus 4, which is 4 volts. Okay, so what will be the total current? I is nothing but E or V by RT, which is E is 4 by 8, which is 0.5 ampere. So we have got the total current. Calculate the current in the circuit. So we have calculated the current in the circuit. Now suppose they ask you that find the potential difference across this end. Suppose they ask you the potential difference across the parallel end. So what is the total combination? 2 ohms. So what will be the potential difference across 3 ohms plus 6 ohms? It is nothing but 2 into 0.5. Because V is equal to R into I, and R is nothing but this. So it is coming as 3 volts. Okay. So this is all the sums you need to do from this portion. So you see students that the sums are really easy. I would again request you students, before you start the sums, I'll be sending you the circuits as well as the sums. Write down the sums first in a rough copy. Then you see the sum one by one, you see the sum one by one, you see the solution. Then it will be easy for you to understand. Hope you have understood these sums.